In this video, we're going to talk about the relationship that exists between price elasticity and total revenue. A firm's total revenue is equal to its price times quantity. Firms that face a downward sloping demand curve know that when they increase their price, the quantity demanded is going to fall. So, in terms of what happens to total revenue, on the one hand, the higher price results in more revenue because they're getting a higher price for each unit they're selling. On the other hand, the reduction in quantity that occurs lowers the total revenue for the firm. So there's two offsetting effects. When firms raise their price, they gain more money from each unit they sell, but they're also selling fewer units. So the effect is somewhat ambiguous without knowing more about the relative magnitudes of these two effects. Whether a firm's revenue rises or falls depends on which of these two effects is larger. In particular, the firm needs to know whether the percent change in quantity demanded is larger or smaller than the percent change in price. And that's exactly what price elasticity measures. So it turns out price elasticity is essentially what determines what will happen to a firm's revenue when it changes its price. If demand is elastic and consumers are relatively sensitive to the price change, when they increase their price, by the definition of elasticity, quantity will fall by more. So when the firm raises a price, they end up with a larger percentage reduction in their sales, and their total revenue will fall. For example, if the demand elasticity is 2, when a firm raises its price by 1%, quantity demanded will fall by 2%. The 1% increase in the price would increase its revenue by 1%, but because they're selling 2% fewer units, that effect lowers quantity by 2%. So the net effect would be roughly a 1% reduction in the firm's total revenue. On the other hand, if a firm has an elastic demand curve and they lower the price, quantity demanded will increase by more than the price fell, which will cause total revenue to increase. On the other hand, if demand is inelastic, when the price goes up, quantity will fall by a relatively small percentage, and in that case, the effect of the price increase dominates the effect of the quantity decline, and total revenue will increase for the firm. If the firm lowers its price, quantity demanded will rise, but it will rise by a smaller percentage than the price has fallen, and as a result, total revenue will fall. If demand is unit elastic, when the price changes, quantity demanded changes by the same percentage, but in the opposite direction. So if the price goes up by 5%, quantity demanded will fall by 5%, and the net effect is that those two things will cancel each other out. So when demand is unit elastic, there's no change in total revenue when the firm changes the price by a relatively small amount in that interval where demand is unit elastic. We can combine this with what we know about how elasticity changes along a linear demand curve. We've noted that demand starts out as being highly elastic on the top left portion of the curve, that elasticity declines steadily, becomes unit elastic at a point, and beyond that it becomes inelastic when we have a downward sloping demand curve. So, combining that information with what we've just discussed, if you lower your price to try to sell more output when demand is elastic, total revenue rises, which is why the total revenue curve on the bottom of the diagram is increasing in the range where demand is elastic. When we get to the point where demand is unit elastic, total revenue reaches a maximum and it doesn't change at that point. Beyond that point, we know that total revenue is going to fall when the price decreases when demand is inelastic, so we end up with this inverted U-shaped curve for total revenue. We can also note that total revenue is equal to 0 at the two intercepts of the demand curve, because if the quantity sold is 0, total revenue will be 0, and if the price is 0, then total revenue will be 0. While it may seem that the point of unit elasticity is an important point because you might think that firms want to maximize their total revenue, but as we'll be seeing soon, firms are not concerned primarily about their total revenue. They're more likely to be concerned about their profit, and this does not take into account the firm's costs. So before we can determine what's optimal for a firm, we have to start developing models of a firm's costs, which we'll be doing a little bit later in the course.